Okay. So cascade form and parallel form. So previous video we discussed about parallel direct form one and direct form two realization. Now we are going to discuss about cascade and parallel form realization, also that pre-warping and warping. So what is cascade form and realization? So this is a cascade form realization formula. So h of z is equal to h1 of z and h2 of z, h3 of z. So this is the way the cascade is connected. Cascade means is seriously the connecting. So x of n is equal to x1 of n and x2 of n and x3 of n. So this is y of n and y of 2 and y of 3 up to xk of n to yk of n. So the input is this is input and this one is output. So this is the cascade format. So this is x of n, y of n, then centered part is plus, then here also plus. So this is look like direct form 2. So there are two like direct form. This is on direct form, this is on direct form like that. So just adding two direct form like cascade form. So here they given the example. So 1 by 8 y of n minus 2 x of n 1 by 3 x of n minus 1. So they given the example. So again we have the formula h of z is equal to y of z to x of z. So y of n is equal to 3. So this is a value. So take the z transform for that. So if you take the z transform, then you got the value z minus 1, z minus 2, and z minus 1, because n minus 1 is there, so it is z minus 1. So after that, uh, that y of z, just to take it, that 1 minus, just take that y of z in outside. So also they take that x of z in outside. So they got the value like that. Then we know the formula h of z is equal to y of z to x of z. So just apply the x of z in numerator and y of z in numerator, x of z in denominator, and this is the formula h1 and h2 of z. So we just simply split that h1 of z and h2 of z. So h1 of z value is, so this is h1 of z and this one is h2 of z. So split the value like that. And finally, we have the direct form 2 realization. So there are two direct form. So based on this h1 and this value is 1 by 2, yes, then that 1 by 4. So this is h1 and this one is h2. So because h1 of z is a direct form 2 form and h2 of z is a direct form 2 form. There are two form they have. So x of x1 x of n is equal to x1 of n, and h of 2 is of x of 2 z is equal to that's another form. So cascading the relation of h1 of z and h2 of z we have. So x of n is equal to x1 of n and y of n. So this is a value. They have one y of y 1 by 2, 1 by 3, and 1 by 4. Y of n. So just take it the value. Just that cascade form means just they adding seriously. So this is the first part and this one is second part. Just add it to, so this is cascade form. Parallel form means just parallelly they will be added. That's the difference between cascade and parallel form. So see this another example they shown. So based on the things similarly same, there's a formula. They find it h1 and h2 of z. So h1 of z is the direct form 2 and h2 of z direct form 2. Then add it in series, then you will be getting cascade form. And so another example. This is also same. Use that formula h of z, h1 of z, h2 of z. So you find it h1 of is a direct form, h2 of 2 is a direct form 2, and finally you just add seriously, then this is cascade form. It's another example. So see that another example. And next one, parallel form structure. Parallel form I already said similarly same, but only the structure is parallelly connected. So this is parallel form equations. So h of z is equal to y of z x of z. So these are equations they shown. So this is parallel form format. So see h1 of z, h2 of z. So previously h of n is z here, h2 of z here, like that it will be the cascade form connected. and the parallel form connected like this. The input and output. Okay, the example they given. So y of n, the value is there. So that's a formula y of z to x of z. So numerator and denominator, and they get it h1 of z and h2 of z. After h1 of z and h2 of z, they will be take it direct from two form for the h1 of 1 and h2 of is direct from 2. Then get it from these equations. These two equations. This is h1 of z. This is h2 of z. After that, they will be connected parallelly. So that is called as parallel realization. So similarly, the next example. So this is the example. Parallelly, they will be connected. Okay, this is example for direct form one, direct form two, cascade form, parallel form. So all the things are in one example. So that is from one, two, three cascade form. That is the previous videos. We just check and check. So this is direct form one. This is direct form two, and this is cascade form. So this is cascade form, and this one is parallel form. So warping, pre-warping. So this is in Butterworth filter, Chebyshev filter design. We can write the following assumption in higher frequency omega is equal to omega. So this is Butterworth and Chebyshev. We will see in the coming part. The amplitude and phase response are affected by this warping effect. What is warping? So amplitude and phase response are affected by this warping effect. Uh, So basically the high frequency will be create a noise. So it will introduce a digital filter as an analog filter. So the effect is known as frequency warping. Actually, you know that in the low frequency, the relation between omega and omega becomes linear. So high frequency create a noise. So the this introduced digital filter as the analog filter. So the effect is known as free warping, frequency warping. The amplitude of the phase response affected by warping effect. So warping effect can be eliminated by pre-warping the analog filter. This can be done by finding the pre-warping analog frequency using the formula. This is a formula they can use to. This is a pre-warping. So warping prevented by pre-warping. Warping, there is a formula is there. So this is a formula. So use the formula. They will be avoid the warping. So warping means so omega and omega. Omega. This is for digital. This is for analog. So if the digital frequency response relation between these two is still non-linear, so low frequency relation between omega and omega becomes linear. So high frequency will be create noise. So introduce a filter as an analog filter. Okay, used in the digital filter as an analog filter. The effect known as frequency warping. Okay, thank you.